Okay, so let me go in the slideshow mode. Hi everyone, good evening. So today we'll talk about Splunk dashboard optimization with post-process search. So thank you for joining the session. And this is Venkatesh. Along with me, we have Somesh, who is a Splunk MVP. Uh, and thank you everyone. Welcome to the session. So I'm working in Splunk from the last 8 9 years. So we are the Splunk consultants at Bitsio. And then, Somesh, do you want to introduce yourself?
Uh, sure. So my name is Somesh. I have been working with Splunk for over 11 years now. Uh, I have been a Splunk Trust members multiple times and Splunk MVP as well. And I joined Bitsio 3 years ago. And since then, we have been working with multiple customers to help them uh, fulfill their Splunk requirements.
Thank you. So let's go to the next slide and discuss like what we will discuss here today. And the agenda for this session is like introduction, which we both did. And the second thing is understanding Splunk dashboards, like why we are using this Splunk dashboards. What's the purpose of having creating some dashboards for the customers or for the users? And what challenges we'll have with the expensive dashboard. We'll talk about that. And so the second point, like challenges with expensive dashboards, right? Um, Many customers feel like running the dashboards for a longer time period. They can't wait for 2 3 minutes to run the dashboard, right? To see the results. So what challenges we have with those expensive dashboards, and how we overcome that as a remediation, it will be shown up in the introduction to post process search, and we'll give a demo on post process search. And finally, Q&A. I mean, if you have any questions in the between, you can feel free to ask. So here, first we'll talk about understanding Splunk dashboards. So while designing the dashboards, we follow some process. So let's break down that design process and walk through that every single phase. We are going to show you exactly how we apply these principles and tools to set a dashboard that we create for the clients. So the process is like first understanding the story you want to tell, and then use the right content and layout, and make it visually aesthetic, and maintain accessibility, and provide accessibility and best practices. So let's talk about the first point: understanding the story you want to tell. So the most important thing you can do when designing a dashboard is think about the audience. Dashboards are meant to be shared, so you need to understand their needs, and more importantly, the actions and the decisions that you need to driven from the dashboard. So all starts with understanding the story you want to tell, and you can do this again by identifying the audience, defining the purpose of the dashboard, and then diving into the data to determine the metrics and the actions needed. To achieve that, we'll start with a brainstorming sessions with the team to better understand the data available we have for the customer and the stories they want to tell with the data. So we started by writing down some high level goals, and then sketching like how the visualizations needs to be shown up, and then writing some questions, like what questions needs to be asked on the brainstorming session. All those things will be discussed under the story, first point. And then choosing the right content and the layout. So you always want to make sure that every component of your dashboard is speaking towards your core purpose. And as you know, you are working through choosing visualization, and you want to make sure that you are using the right visualization so that the audience understand the underlying data. So when you build a dashboard and when the customer looks at your dashboard, make sure that by looking at the dashboard, the customer or the user can analyze something or get some use case out of it within, within first few minutes. By looking at the dashboard, he needs to get some idea. We don't need to explain it. In that way, we need to design the dashboards. So after designing the dashboard, mainly how we want to show them that particular dashboard, what kind of visualizations we want to show up, and it depends on use case to use case. So each visualization type has a specific use case. Do you want to show comparisons, or do you want to identify patterns or anomalies, or do you want to investigate flows and trends, or or you can use the metrics data or statistics table, which I didn't shown up here. So every visualization will communicate the data that we have. So that's about the visualization part. So now go to the third point, make it visually aesthetic. So, and another great way of bringing life to the dashboards is using the colors, because the colors are the most important thing, which plays important role when we are looking at the visualizations. So if it is just a plain color, one single color, it doesn't make any uh, you know um, you can't take a look at the dashboards or visualizations, and you can't make decisions. But when we have some colors like the red color for anything that is stopping for any errors, and for green color for something is going good, or if the trend is going good, we can show up the green colors. So those we call as semantic colors. So use those colors for better visualization. So, and next, once we get that, so we'll develop some dashboards and reports, sorry, on dashboards based on the requirement that we gather. But when developing the dashboards, what we if we have some expensive multiple panel dashboards? So the challenges that we have here is mainly three. That is high resource consumption dashboards, and the second one is concurrency limit users, concurrency limit issues, and other is such job disk quota issues. So we mainly first let's talk about high resource consumption dashboards. So for example, this when you run this query, it will show you up which dashboards or which panels show you how much resource it uses and how much time it took. If you see here, you can see the run duration here, and how much memory usage it is taking to run that particular search, and the event count it will show up, and the result counts, and how many events it scanned. Everything will be shown here using this high resource consumption query. So first of all, if you think that in your organization or at your client location, if you think that there are some dashboards that are high resources, you can use this particular query, and then you can modify those things. The remediations will be shown up in the next slide, and what are the remediations we need to take care for this uh, expensive dashboards. And other thing I would like to bring here is, maybe some dashboards might have n number of panels, and it will be using only once or twice. So we don't take care, I mean, no need to take care of those dashboards. For example, let's say we have a dashboard, and we have n number of panels, and people are using continuously for that particular dashboard. For those cases, we are concerned about that, because those dashboards are taking longer time duration. And then for those kind of dashboards, we need to use the post processors. And then coming to the second challenge is concurrency limit issues. For example, for users who use dashboards all the time, or most of the time, it's really great to know like how to optimize them. One thing that really trips us a lot of users that have noticed is concurrency issue, because for users they have very low disk quota. So that's the reason this concurrency issue happens. For that, for example, when a user opens a dashboard that might have 20 panels or 10 panels running all individual ad hoc searches, then probably the user is going to face a problem which looks causing the concurrency issue. So if you want to know there is any concurrency issues or not, you can run this particular search in your environment. And the next thing is disk quota issues. For many of the users who who are not admins, they have default is 500 MB. So if they want to know how much disk quota they have, and if there are any if they want to uh, I mean, if they want to run the same dashboard which has like 10 or 20 panels, they will face the disk quota issues. And if you want to look for the slowness of any dashboard, you can use the same command, search query, to run the dashboards. Sorry, to show what dashboards it's causing the issue. So all these issues will be resolved using few techniques. So we can optimize those dashboards using for example, let's say we have a dashboard that has um, we have a dashboard which has 10 panels, and each panel is running for the last 24 hours, or you know what we call or 12 hours or something like that. But you don't want the data to look for last 12 hours. You want to look only for the last 60 minutes. Then no need to run that particular search for the last 12 hours or 24 hours. Reduce the time range in the dashboard, so that you can so that the performance will be decreased, and the resource usage on the particular dashboard will be reduced. And also you can go for event sampling. For example, if you are doing a time chart, let's say you want to count the status code in access logs. Do you really need to count every single event, or it would be okay to just count one of 100 sampling? The ratio you are looking between the allows and success is still good enough for you. So uh, then sampling could be a great speed up. And uh, and, and also it won't spend much of the resource usage on the search. So in some cases you can go with event sampling too. And the other thing is you can adjust the refresh interval for to a higher frequency. For example, let's say you have two different panels. I mean, let's say you have 20 different panels. One is for the issue showing up, and other 10 issues 10 panels are for the issue showing up, and other 10 panels is for the troubleshooting that particular issue. So if a customer is looking at that particular dashboard, he don't want all the panels to be refreshed at a certain interval of time, right? So what you can do is you can increase the refresh time. Like if he is looking at the only two panels, one is from the issue and other is from the troubleshooting issue, then he can use the refresh button only at only for those two dashboards. And other thing is, like, you can split the dashboard with multiple panels. If you're having n number of panels related to the application in one dashboard, you don't need to have everything on one dashboard. You can split it. Okay, the first part, the issue part is on the one panel, and the troubleshooting part is on the other panel. Sorry, another dashboard. All those things you can split. If the same application is talking to the some other application, you can have multiple dashboards. and job caching. So, Miss, could you talk on this job caching and that? I mean, can you take over from here?
Sure. So basically, the dashboard optimization will vary based on different use cases that you have. If you have a panel which is relying on a data that only generated once per day or only a few times per day, so if you refresh the dashboard and the data is not going to change, so instead of rerunning the whole search, what you can do is you can save that panel search as a save search and use the load job command to fetch the latest run of that scheduled search or save search. That way, when the dashboard reloads, it's not rerunning the whole query all over again. It's just using the search results from its previous run. So that will save you precious resources of CPU time and save you all the reprocessing of the search query. Other important dashboard optimization technique that we use is the post-process search. So in the post-process search, um, instead of running, say, 10 different search, if your searches are similar, specifically if they are being derived from same data sources or same source type and index, you might have an option to combine them into one common base search, and then uh, all the panel searches will work on the result of the base search. So that way, the number of searches will get reduced, and since all the panels are working on the same base search result, they take lesser time to finish. So, guys, if we can, yeah. So we optimize a dashboard by using post-process search by combining multiple similar searches. And when I'm talking about similar searches, we're talking about searches which have same base search. Base search is nothing but the search portion before the first pipe symbol that you use. So if you're using index equal to foo, source type equal to bar, and then some uh, filter on a field, and then there is a second search which is also using same index and source type, but using a different value for that same filter, then you will have an option to combine uh, those two searches into one. So you'll your dashboard will run one base search, and then all the panels will perform additional processing on the result of the base search. Uh, Using post-process search, you have an option to just create one base search to power all the multiple panels, or you can chain multiple base searches. Uh, Once, like after using the post-processes, the number of searches will get reduced to just the number of base searches that you have. And because we are combining multiple searches into one, we might have to do some aggregation based on multiple fields. So the base search might take more resources than the original search, individual search. But since instead of multiple searches, we are running just one search, overall it saves a lot of resources. So
Thank you so much. So let's go to the demo session. You share my other screen. Yeah, 1 minute. Do you guys see my other screen? So much, can you see?
yes, I can see that.
Okay. The Splunk dashboards, you can see that?
Uh, no, I
No?
think we just seen.
Okay, 1 second. Let me stop and listen. I think, can you see now?
Yes, it's visible now.
Okay.
Okay, so for the demo purpose, we have created two dashboard. If you look at the bottom two entries, Splunk Health Reporter Statistics. This is one makeshift dashboard with four panels, which is powered by uh, introspection internal index. So that dashboard that you are seeing highlighted is using four panels, and four search. All panels have individual searches, and the one below is the optimized dashboard, showing the same four panels, but they are powered by one single base search. And then we have a dashboard which will do the comparison of performance of both the dashboards. So Venkatesh, we can open the first dashboard. So as you can see, it has four visualizations. First one is showing the uh, distribution based on the color. And just for your information, this is powered by the periodic health reporter data that every Splunk instance generates. So we have two key fields in that data. One is the color and one is the feature. So every feature will show uh, the color, green, red, and yellow. Green means all the features are working correctly. Yellow means part of the features are uh, not working correctly or are in the are about to turn bad, and then red is definitely that feature has issues. So we are showing four panels, four different visualization. Two of them are showing metrics and comparison, and then bottom two are showing trend, or basically the time chart, or based on different fields. And if you open the second dashboard, it's basically showing the same thing, but as I mentioned, it is using one single search. If you open the third search, or
Do you want me to show the source of
uh,
the?
let's refresh the dashboard first so that we can show the performance data.
Yeah. Okay. So
And this is as well. So basically, we have a REST API query which queries the job data and compares the uh, results based on the dashboard name. So if you see, the first panel is the statistics about the first dashboard. Uh, there were four panels, so you can see there were four searches being run, and the first row is showing the aggregation of resources and runtime for the overall dashboard. So you can see the dashboard total took 22.96 seconds to run all four searches. So that's 22.9 seconds of CPU time that it used. 0.52 megabytes of disk, that is the dispatch directory size. The event count is the number of events it scanned, and the result is the 39 results were written. And then the other statistics are there. And if you see, the optimized dashboard is just have one single search. That search took just 2.4 seconds. So you are saving a lot on the CPU time slash the dashboard load time. The disk usage is also very low. You can see the disk usage is higher than the individual searches on the first panel that you see, but overall it is less than half of the overall disk usage that the dashboard used. The event count is also less because we are not running multiple searches. The result count is higher because we did aggregation on multiple fields to power up four panels. So for runtime, we are saving up to 90%. For disk usage, we are saving up to 50%. And that number will vary based on dashboards. So Venkatesh, could you share the dashboard code for the first dashboard?
Okay. The source, right?
Yeah, as you can see, this is the first panel is running an individual search on the internal data. It has one search, and then if you scroll down, the second panel also using its individual search. Third and fourth panel are also doing the same.
Yeah, this is the fourth one. Yeah.
Yeah. And if you look at the optimized dashboard, there will be one base search at the top. It is running at the same time range, running at the same base source, index equal to internal, source slash Splunk D and component periodic health reporter. Uh, of course, because we are combining multiple queries, so we need to make some adjustment because the feature field was not available in every event. We added a police there, and then we are generating two statistics. One is based on time, and one is just the count. So in the base query, we are including the time based aggregation as well. So if you look at the first panel search from line 14 to 15, keep the base search open as well.
Okay.
Yeah. So basically, the search query that you are seeing in line 15 is getting appended to the end of base search. So base search is generating count based on time, feature, and color, and where time is bucketed into 1 day time buckets. And from the result of this, we are just doing a sum of count based on the colors. It's effectively generating the same result set, but it is using one base search, and the base search is specified in line 14 with the attribute called base. So the base search will have an ID, and then using that ID, you can specify one or more child searches.
And we can use two base searches in single dashboard. Can we use two base searches in a single dashboard?
In single panel, you cannot use two base searches directly, but you can change them. So
Okay,
basically, you can
not in a
create,
single panel, but in a single dashboard we can use it, right?
you can use multiple base searches.
Okay. So whatever the ID we are mentioning here, we need to call in the base, right?
Correct. Yeah. So in this example, we combined four searches into one. I had one customer who had 17 panels, and we combined them into eight base searches. So you'll not combine everything into one or two. Sometimes you have to create multiple, but you still save a lot in terms of resources because instead of running 17 searches, we are now running just eight and saving everywhere else as well. So scrolling down to the second panel, you can see is using the same base search and just running a chart command based on field and color. It is very similar to the original query, but since we are running on top of the base search, instead of using direct count function, we are using sum of count. So it's doing a post processing on the result of the base search. If we scroll down, the third panel, you can see we already had the time-based aggregation based on the time field. So we were able to do the time chart command based on the field color. And if you scroll down, similar thing has happened for the feature field. So essentially running uh, just one search to generate four different visualization.
Yeah, it seems it. Yeah, we saw that here in the run duration we are saving almost like more than 95 percentage here. 95 percentage of runtime
Yep,
because yeah, for most of the customers, I don't think they will implement or not using the post processing search because it's really helpful for them, mainly for the users, right? Because the users have low disk quota, right? So usually when they run a dashboard having five different panels, that's it. They need to wait for they need to delete the job, or they need to wait for few minutes until the jobs end, and they need to until they get a new disk quota.
correct. Yep.
Yeah. Mainly admin.
Working for a company, you'll get a lot of tickets that my dashboard is loading very slow. The
Yeah,
reason they have like 20 panels, there this concurrent search limit is three. So search is just loading three searches or three panels at a time. So it has to take 6 or 7 iterations of its concurrent quota to complete or load the whole dashboard.
Yeah. And also increasing the concurrent search limit is, it all depends upon the size of the environment and the resource they have. We can't simply, since it taking a lot of time to run a dashboard, we can't increase the concurrent searches as well.
That is correct. Yeah. Every search head will have a finite set of CPU and memory. So we cannot always increase quota for everyone.
Yeah,
So that's why applying the optimization technique is the way to go. Or that should be the first step that
yeah.
should be done.
Okay. Also, can we apply this post processing search for tokens also, right?
Yes. So any dashboard which is using tokens or form filters, the base search will work the same way like a regular search.
Okay. If anyone has any questions, they can. We are open to questions too.
Yes, I have a question. This is Crispin here. With regards to base searches, let's say you have a data model, right? And with the data model, we'll have to use the t-stat instead of the index. So, do we actually use base searches on those data models wherein we have different node names? Would that work well?
I think the one data model search works only on the one base search, but you should be able to combine using append command or uh, some other uh, multiples, some other commands using which you can run multiple searches like join or
Okay.
uh, yeah,
All right.
union.
Yeah. Thank you.
Any other questions on the things that we covered so far? Or if you want to go back to presentation and have some questions there, we can uh, cover that as well.
And how many guys? I mean, how many of you guys are using post processing search at your organization?
I've used base search before on other dashboards, but in my organization that I'm working right now, so I have a data model, and then I built a dashboard based off of the data model, and these searches are mostly coming from different nodes because I mean the data sets, we have different data sets with child data sets on them. So I'm just wrapping my head around maybe to see how I could improve on that using the process search now. But I'm not currently using it on my dashboard and it's a little bit slow. So what we did was we had a UAT data model and a production data model. So as we put logs into the UAT data model and we onboard the logs and we validate that everything is fine, we'll move it to production and free up space on the UAT data model. So that way we're able to like validate what we need to validate on the dashboard. But and then the production data model is actually accelerated, so that one is fine. But I'm looking on ways on which I could use the process search on my UAT data model, wherein I could create a base search and I mean, like um, um, like you guys said, use join or something like that to bring in all those queries together. Yeah.
Okay.
Yep. And Chris, obviously I don't have access to your data, so I cannot say for sure, but you might be able to create a base search based on the root data set that you have. Right
Yes.
now, you're running based on the child data set, right? So you can run the
Hmm.
base search based on the root data set and manually add the child data set constant on
Okay.
the base search.
Okay. Gotcha. Yeah.
Okay, if no one has any questions, we can end this call. And if you have any topics that you want to discuss in this user group, just let us know so that for the next presentation we can work on that.
Okay, I'm going to stop recording.
Yeah.